All right, Victor, how you doing, man?
Good, good. How are you today?
Where are you calling in from?
I'm calling from Seattle.
Seattle. Today we'll be talking about bringing the power of Google's infrastructure to Apache Iceberg. I'm very excited to hear a talk about BigQuery and how all these different pieces fit together. I will be back in 15 minutes, and we're going to have an even longer session for Q&A.
My name is Victor, and I'm software engineer in BigQuery. I am working in a group that is tasked with big lakes and similar technologies. And Apache Iceberg is part of the technologies that we wanted to talk about today. So I'm going to go over the general overview of BigQuery, and then I'm going to discuss several existing integrations that we have that work with Apache Iceberg. A few years back, we didn't have anything, like 4 years back, and now we have several offerings, and we're hoping to have even more soon. In general, BigQuery is, unless you don't know, is a fully managed and serverless system for data processing. It has completely decoupled storage and metadata layers, which are scaling independently and on demand. And basically, users and customers don't need to think about scaling or especially having their resources running while there are no jobs or no queries to execute. So this is different from than traditional node-based computing warehousing, where you have to have your nodes possibly running at all times, even if there are no serving any workloads. So this gives you big flexibility and cost control over what you have to do. The engine is known as Dremel, also scales extremely well horizontally and vertically, and provides modern SQL 2011 compliant SQL language and CLI, REST API, and other drivers that you can use to talk to BigQuery. Now, the gamut of tables that BigQuery provides is pretty wide. So on the left, there are self-managed Iceberg tables or even self-managed external tables. There, the data is read-only. You manage all the data. You manage all the metadata, and BigQuery just provides you querying. On the other side, you have the BigQuery managed tables, which leverage all the capabilities that we have. The storage is managed, the metadata is managed, it's all fire and forget, and it gives you all the flexibility and control over the data and metadata. On the other side, because this flexibility and performance come at a cost that both the data and metadata are in proprietary format, and unless you export or take out your data, you don't have direct access to the data except the methods that BigQuery provides, be that query engine or the read API. But it provides all the features that enterprises require, automating scaling depending on the loads, controls and features, compliance, disaster recovery, data residency requirements, and column and row level security and whatnot, including materialized views and so on. And in the middle, we have our more recent offering, which is Apache BigQuery tables for Apache Iceberg, which provide you some middle ground. The metadata is still managed by BigQuery, but the data is in open source Parquet, and you can export metadata in Iceberg format to query from external engines. And we'll get to those details later. So the starting on the left, is the self-managed Iceberg tables. They come in two flavors, and we'll go over the capabilities of each one. So one are external Iceberg tables. In that case, users basically have to manage the data and metadata themselves. It can be done via Spark or other engines, and Google BigQuery basically receives the pointer to the metadata. And at that point, it executes the standard queuing, Apache Iceberg queuing processes, reads the manifest files, reads the Parquet files, and serves the query. By virtue of being part of the BigQuery execution engine, you are gaining on the other side all the controls that you might not have otherwise in the open source, such as row and column level security, materialized views, and search indices. So in that case, for example, you can generate your data or stream it using your link into a big lake that will be managed as an Apache table, but later your data analyst can query the data by applying those positive security and visibility controls with data masking and column level security. The next level up is the BigQuery Metastore, which is our most recent offering that recently has been recently graduated to general availability. This executes as a standard Iceberg plugin where there is a jar file, or now it's currently merged into upstream Iceberg repository, so it will be available in every release starting 1.10. At that point, the code or library on the engine side will manage all the file interactions, the metadata, and whatnot. But the BigQuery will act as the ultimate catalog and the source of truth for the metadata. It will store the table information, the pointer to your metadata, and will ensure that all the data is correct, and it leverages the same availability, disaster recovery features for that part that BigQuery stores. In addition, if you query those tables via BigQuery rather than through your open source engine, you are receiving same exact features as we talked just now for external Iceberg tables, including column and row security and possibility building of materialized views and search indices over your data. In addition, because by virtue of it being a library, you can still use it directly from your open source engines, but it is also possible to run it from other GCP offerings such as Dataproc, which natively integrates with it and just works out of the box as your another Metastore. And as I just said, yeah, it leverages all the same querying engine, which is Dremel, and features all the enterprise features that might be required. Now, going to the managed Iceberg tables, which will be soon launching to general availability. In this case, BigQuery is the source of truth for both metadata and the data. And the data is stored in a Parquet format in a user GCS bucket, and except for one case which we'll discuss later, immediately at the completion of your DML operations or load operations, it will be available in the bucket. The metadata currently is exported on demand. So the metadata is stored internally in our proprietary formats, but the Iceberg metadata can be exported on demand whenever user needs that. And soon it will be coming to, then it will be automatically exporting it as the data inside the table changes. So you will have fresh Iceberg metadata available in your GCS bucket for consumption by external engines almost immediately. Because the metadata is stored in our proprietary formats, it allows same optimizations that we can apply to our native tables, which means that there are features like enterprise control, as we discussed, the column, row, and row level security, data residency, and whatnot. In addition, it supports several more advanced features. One is high throughput streaming using Write API, which is one of the best offerings in the market. It allows you to stream several gigabytes of data across all your streams per second. And here the difference from the previous slide is that data will be stored temporarily internally while it's being converted into Parquet format. And we'll go over architecture in the next slide. Another thing that BigQuery tables for Apache provide is that because we own all the metadata internally, we are able to apply same data optimization, ensuring the Parquet files are sized appropriately for optimal query performance. We're applying our internal proprietary algorithms to determining the sizes, computing statistics to ensure the proper performance and whatnot, data reclustering, and garbage collection. So as soon as the data is going outside of your time travel window for querying, the data is collected, so you don't have to pay your GCS bill unless you need the data for longer. So going back to the hyperthread streaming, I wanted to discuss a little bit the architecture that powers it. So the data arrives at a write API front end, which is supported by several libraries in various languages. At that point, the data can be partitioned into several streams. It can be sent by one stream, and it's all being consumed by our stream servers in the backend. Those stream servers collect all the data and store it in our internal proprietary formats for the time being, while the amount of data reaches expected amounts that would necessitate its conversion and export into Parquet format and the metadata. When that time arrives, the internal system will convert all the temporary data, convert it into Parquet format, and export into your bucket. And the metadata will be merged into the rest of the table metadata, and then it can be exported and processed by external engines should the need arise. Interestingly, though, if you want to access the temporary stored data right now, you will need to use either BigQuery engine or the read API connector from external open source engines. While the data is stored, obviously, it's also subject to all the controls as discussed above, including CMEC. If your table is encrypted with your custom key, then it will be encrypted and all the data will be stored. From BigQuery, you can always query all the data, including the union of the recently streamed and already committed data to the table. So the features that are coming soon with the BigQuery managed tables are just going to be general available soon, and it will include continuous Iceberg snapshots. It will include time travel support for both from BigQuery and from the OSS engines, and it will have change data capture capability in the write API and high throughput streaming, where you not only can write data as append only, but also you can send changes such as deletions or upserts, which is a highly requested feature. And as it has been announced at the next, we are also working to support Iceberg REST interface so that it is possible to manage the Iceberg tables in your BigQuery via REST catalog rather than the plugins jars or the code running on your cluster side. And that's what I had planned for you today, and I'm ready to answer any questions you have.
Awesome. Victor, thank you very much for coming and sharing with us. Can you share your screen one more time? And can you go back to that system diagram?
Certainly.
Okay, by the way, all right, so
this one?
I will put my question aside for a minute. I'm already seeing some questions then show up. So first is, what is the speed of high throughput streaming?
So as I said, like the ingestion capabilities are above several gigabytes per second. across all streams. Like if you're streaming only web stream, it's a bit restricted. But if you have several streams and you have several streams ingesting, yeah, it's the default limit is 3 gigabytes. But if you have a good use case, and it can be increased even above that.
Yeah. Okay, John is asking, is there any cost to the customer for the internal temporary storage and the conversion to Parquet?
No. So the bill is basically you pay for the write API, whatever the price is. It's standard as for native tables as for Apache Iceberg tables. There is no additional separate line billings for either temporary storage or conversion.
Okay, we got another one from Vinod. Are you able to comment on how the table types are distributed across BigQuery native format versus Iceberg or open table formats?
I don't think I have, like, you mean like the number of tables or like proportions of tables of native to Iceberg? I assume. I don't think I have that information, but currently the majority of tables that BigQuery has are native tables.
Yeah, I think he clarifies here the percent of tables in each category.
No, unfortunately, I do not have that information.
We got another one here. And does BigQuery differ on compute slots, so limited to 2,000 per GCP project, when querying self-managed versus native versus big lake tables?
So the slots are basically shared across the compute engine. Like, so the Dremel is the execution engine, and whatever queries are done through Dremel are built to your slots, irregardless of the table type.
Let's see, we have another one here. Surendra is asking, Victor, can you explain about time travel in BigQuery Iceberg?
In the Iceberg? So right now it was because the product was in the preview phase, there were some edge cases we didn't want to release it to general availability for people to use if we weren't sure of the quality at the time. So those are all fixed and will be released, and it works standard way. So if we're talking about internal metadata, it's supported out of the box. If for Iceberg, like for time travel, you need to store appropriate snapshots and snapshot history in your metadata, and that will also be available. So you can curate with time travel from your open source engines as well.
We got another one here from Imtiaz. Does your system only support Parquet format or also supports other formats like ORC and Avro?
So depending on which one. So external Iceberg table supports both ORC and Avro. The managed Apache Iceberg support only Parquet.
Okay, let's see. I think, by the way, folks, you could feel free to just drop your questions in the Q&A tab, and then others can upvote them. Otherwise, I kind of have to fish them from the chat, and it's a little more, at least I don't then know which ones are most popular. We got another one from the chat. Can you comment on how a BigQuery costs on slowly changing dimensions operations? Slowly changing dimensions operations.
Yeah, I'm not sure.
I don't know if
I understand the question.
Yeah, I don't know if you guys
follow up.
Yeah.
Yeah, I'm not sure I understand the question. Well, sorry, but
Tian Hui, if you want to explain a little bit more, what do you mean by costs? Do you just mean like the extent to which slowly changing dimensions are like operations on slowly changing dimensions are like adding up to increasing costs?
In general, for managed tables, the storage is basically built on how much storage you have. For the Iceberg tables, obviously, whatever GCS is billing is whatever how much data you're putting into your bucket.
Yeah.
So slow changing or fast changing, it doesn't affect much.
What about any plans for managed Delta Lake tables?
No, there are currently none that I'm aware about.
Okay, we're almost.
Delta lakes are those supported same way as Iceberg tables, the self-managed. So you are able to query those through BigQuery, but they are read-only.
Read-only. Okay, we got another one here. Is it efficient to use native BigQuery tables versus creating external tables in BigQuery with data in blob storage written in Hudi or Iceberg?
So yeah, especially if you're going to query them from BigQuery, it's more efficient to create them in BigQuery because we have all the necessary metadata internally, which is faster to load than going to the GCS bucket and loading it from there. And the format is internal and proprietary, which is faster for us to read than it would be Avro or JSON in general. So
okay, I think we're going to keep it to the last one for this session. John Esperanza is asking, is there any configuration available for data compaction on Iceberg tables?
So for managed tables, I assume. So those are all managed internally by our algorithms. They're changing over time. They're not really public, all the thresholds and whatnot. Based on our history and query performance, we determined what would be the optimal sizes for our engine, and that's how we determined those.
Yeah, that's fair, especially for the managed solutions. Victor, thank you very much for coming and sharing with us and joining us for this session.